Hello and welcome to another exciting Cooking with Unity. I'm your host, Max Burrow. With me is Jeffrey Hawthorne.
Hello.
Phil could not make it today. He apologizes. He's just been busy and tired and stuff. They've been working him to the bone at his workplace. So we're starting a new project. We're doing kind of a Diablo-esque game. It's not going to be the same theme, but it's going to be that type of gameplay where you have a randomly generated dungeon. You go into the dungeon and you kill a lot of enemies using cool powers and abilities and stuff. And we haven't done an RPG type thing, so this is going to be a foray into something that people have asked a lot about. One of the big reasons is they want to know how to do the data management stuff of that. And we're probably not going to touch on that today, but that is something that this project is going to have to touch on because we're going to want to have some loot and stuff and randomly generated things and have an inventory system so you can see what you have, stuff like that. So this one could get pretty complex. As such, we're also using both the episodes while we work on it. That may be a temporary thing. We're just going to see how it plays out for the first few weeks and then see how people like it or not. And we'll see what we do from there. So let's actually get started on things. So it's a brand new project. So we're going to start by making a brand new repository. We're going to create a new repository on GitHub.
It's kind of the same as the regular shows too, though. It's
What?
just kind of go for a few weeks and see how it goes.
Yeah,
See
well,
how
I mean, it's
people
always
like it
it's
and-
always the case, but yeah, and see how we like it too. That's the other side of this thing is we are selfish. We're just like, yeah, I'm done with that game. I don't want to touch it anymore. But yeah, this one I kind of like. I have hopes to kind of turn this one into an actual like released game project for sale that's actually like decent. But I've had that thought before and failed at it, so we'll see what actually happens with this. So, what are we going to call this game? I actually do have a name for it. I'm going to be calling it Scape. Yeah, and we'll initialize it with a README. And we will add a get ignore file for Unity.
Our NDA requires you to tell all your friends.
Yes. Our non-disclosure agreement says that you must tell 10 people that you know about this game. And that we're making it, and that way we can maybe sell it or something. So
they'll know about the channel.
Yes.
Too.
Yeah, truly. So you started this game, Scape, and I'm going to... temporarily just put this into, I'm just going to call it Scape, but not put it in the right place. Scape project is what I'm going to call it. And we're going to put it into wherever GitHub is.
Project should go first. Project Scape.
Project. That's very, very temporary. This is going to be changed in just a moment. The only reason I'm doing it this way is because I could sync to the project, but then there's an empty directory, and then I create a directory and it doesn't like it, or I could create a project directory that has the different directory name and then migrate the contents, which is what I'm going to do. So we're just going to change one quick setting in editor, or two quick settings in editor. We're just going to make it so that the visible meta files, this is a personal choice. I like to know that they're there, and force text on the assets. And I'm going to go ahead and save a scene so that this assets folder will make it in. So we're going to call this just test, and it's not going to have anything in it just yet. So now we're going to open up source tree. We're going to add source path URL. We're going to add Scape. Clone that baby. And now I am going to go into GitHub. We're going to go into Scape project and just copy all this stuff and paste it into Scape. And I'm going to remove that. So now if we open up Unity, drag this in, open project, sweet, there we go. And we're going to check in what we've got so far as our initial check-in. Initial project check-in. There we go. We should be ready to rock. So, Rock. Yeah. So I'm going to actually pilfer something from Breakfast with Unity real quick, just because we did that this morning, and I think that it's fine to pilfer from this occasionally. We did a dual stick shooter setup, and I'm just going to play around with it to start with here. Dual stick shooter controls. What do we want? We want shoot on axis input and move on axis input. Those make it in? Yes, they did. Good. Alright. So, we're going to create a very, very simple test scene. We're going to create a plane. We're going to... oh, this is like a perfect angle. I'm just going to align with view. I don't know what... Oh. Undo. I want to take the main camera and align with view. There we go. Get that nice ISO view. Yeah. All right. So, so you have this plane. We have the camera, and we're going to create a 3D object. No, sorry, a light, directional light, and create a cube. And this is going to be our little player character for right now. Move him to 0.5. And let's put move on axis input and shoot on axis input on this guy. We might have to tweak a few little things here. And let's create a sphere. This is going to be our very temporary projectile. Create a material red. Just make Phil so happy that we're using red again. But he's not here to enjoy all the redness. And I can probably grab move forward from somewhere in here too. I'm sure that we've used it before. Move forward. There we go. That work? Yeah.
It always looks like it didn't.
Yeah, it really does. Like moves back to the other location. It's like, okay, that didn't work, and then it does work, so. And we'll make this move 10. Make the cube move 6. And we will create a prefab of the sphere. We're going to delete the sphere in the scene. Put the sphere in here. And what do we want to do? Let's set up our controls real quick. Input. We're going to set this up at kind of like a dual stick shooter to start. We might change this to a click to kill, and we might also change it to something touch related for mobile. But I've been playing some Diablo 3. 3 sounded too low, but it actually is Diablo 3. And they have kind of a neat little control scheme if you're playing on console. We're not going to be duplicating it entirely because there's just kind of like a single stick game type thing. But yeah, so we're going to make a horizontal 2 and a vertical. Actually, let's call it horizontal. Let's actually call it what it is. Horizontal fire. Horizontal. What should I call the axis for aiming? Horizontal aim is what I'm going to call it. Horizontal aim and vertical aim. And so horizontal, we're just going to use A and D. And horizontal aim, we're going to use left and right. And vertical, we're going to do the same deal. W and S. And vertical aim, we're going to do down and up. So now we can change this to horizontal aim, vertical aim. And if we hit play, so if I hit W, it moves in one direction. These directions are kind of skewed because of the way we have the camera set up right now. But it does work. I need to figure out why it's so choppy on the rotation stuff at some point. I think it's because we're relying on the smoothing to smooth this out, and the way that it's doing that is just not working with us very well. Maybe I'm doing something really stupid. Hold on. Shoot on access input. Yeah, I don't know why it's so choppy. Oh well, this is a start at least. So right now the directions are not right, and the way I'm going to deal with that is I'm actually just going to make sure that the game is actually locked to the proper access here. So we're going to look at here. So what about this? If we create, if we tell the camera to go to where we're looking, align with view.
So with the horizontal and vertical set up as axes, the arrow keys do simulate analog in between. Just press down and press up.
Yeah, yeah.
So it should have been, or it.
Well,
so
I mean that's the reason that we're getting like see all that kind of gradient of angles there. So now I've got snap, so we can snap it, but it will actually try to rotate if it's somewhat close. But I'm not sure why it's so choppy. It just seems like it wouldn't be that choppy.
Is it the sensitivity or something in the input settings?
Yeah, it might be.
Or the dead space, I don't remember what they call it.
Alright. So we've got very basic movement and firing. This does not resemble a Diablo game in any way, shape, or form yet, but other than, well, I mean, we're producing a lot of red. I don't know, there's not a whole lot going on here. So I shouldn't be so bothered by that choppiness, but I am so bothered by that choppiness. Right, times input get access, horizontal access, forward times input dot get access, vertical access. Oh, I see the problem. So this says if can shoot and shoot direction dot square magnitude. So can shoot is only being set when I can shoot next, so I can't rotate in between. So this should actually be happening regardless. Well, actually, not regardless. It should be. Do this. If can shoot. There. Now it won't be choppy anymore. That makes sense. Let's see how that looks now. Yay! Super smooth. That's the way we wanted to see it. Yay!
Does it automatically shoot when you're holding in a direction?
Yep.
That's how it's set up?
That's how it's set up right now. So if you press any direction on the right stick, or in this case the arrow keys, you'll get shooting. And if you release, it will eventually stop shooting. It doesn't immediately because of the time it takes to return to center because of the gravity. We could probably make that a little bit tighter. Let's go ahead and do that real quick. I do want a little bit of this just so that if you're on keyboard it will work. But let's make it so it's gravity of 10 and sensitivity of... What does sensitivity actually do anyway? Move towards value for digital devices. There we go, units per second. So yeah, let's do 10. 10, 10, 10, 10, and 10, 10. Cool.
See how long it takes to stop firing.
Feels pretty good. There's a very slight delay, but it's not a big deal. All right. So we got basic movement. Save all. Let's see. What should we do next? We could do some experimental, like, just damage stuff, just show how enemies would be damaged by this stuff. Or we could work on map generation. I don't think I have the brain for map generation tonight. We're gonna have to do that on another show. Let's get some basic collision stuff. Just some ideas on how we're going to handle that portion of things. So first off, let's look at movement collision. I'm gonna create a wall. Z will make this 10. Oops. Why did I think that was going to work? Oh, wait, 45. How did that become 35? There we go. There you go. So right now, if we move into there, we move right through it. So that's not going to work for our game. So, so how are we going to fix that? So let's call this the player. And let's see what we're going to do with the player here. So currently we're doing move on axis input. And this just moves us. It doesn't seem to care. So we're just changing transform.position. Cube currently has, oh yeah, sorry, player's gonna need a rigid body, so physics, rigid body, and I'm gonna try it as kinematic, and that's probably gonna make it so that we can just move right through. Yep. If we didn't make it kinematic, can we move right through? I don't actually want to use this, but yeah, that does kind of do some things, although it will seriously make our game weird. Oh yeah, we're getting real fun stuff now. We're shooting ourselves around with projectiles. So we don't want our character to behave in a physical way in the world, but we do want them to be blocked in by collision. So I'm going to try something that I don't think is going to work. I just want to try it to see if it would. Right now we're using transform.position. I'm going to try rigid body.move position, and then we're going to give it the same coordinates. So move position, yeah, we'll see if this just works similarly. And we'll need to put an end thingy and a beginning thingy. Save. I don't think this is going to actually change a thing, because we're still kinematic. It probably isn't doing anything for the... Oh, maybe I'm wrong. So that was interesting. Why did we... Oh, I see. So this is actually telling you the position you're moving it to. So it would be transform.position plus this. Save. So we're moving... Nope, we can still slide right through things. That's kind of what I thought. Sweet. Alright. Alright, so time for raycast collision to the rescue. So what we're going to do is... we're going to go with kinematic. We're going to move our thing around. We're going to use raycast to determine if we shouldn't be able to move there. Let's try it. Alright, so if physics.raycast actually, let's not do this in the movement. Yeah, let's do it in the movement. Physics.raycast transform position we're going to do raycast in the direction that we're moving. So let's call this the move direction real quick. Vector 3 move direction equals that. Move direction dot time. Okay. So back to what we were building here with our raycast. So transfer up position, move direction. Distance would be oh yeah, we have a speed component here, don't we? Let's actually do the whole thing here. Alright, so move direction. The distance we'll use is speed times time dot delta time. And we just care if we've hit something at this point. So I think this is all we need. Let's just double check the signatures here. So we want origin, direction, and distance. Actually, do we have just origin, direction? Yeah, we do. I wonder what distance. Yeah, let's use the distance here. So yeah, that'll be all we need. So if physics raycast, if not physics raycast, there we go. So let's see what this does. Hit play. We move, we're moving, we get to the air, and it stops. Cool. It kind of stops inside of the thing, but it is working. Kind of can't glide very gracefully against it either. That may be something we'll need to adjust. Like I'm pressing into it and...
Let's add another wall at the top right and see how it handles corners.
Alright, sounds good. Duplicate, -45, and move it into position. So I'm in the corner, and I can get out. I just, like if I press up here, I don't move up into the left because it's getting in the raycast. So we may have to make this a little bit fancier if we want to have gliding along the edges, which I think would be optimal. You kind of want it to feel like your character has movement capability. We also don't want it to be quite that short a radius.
Especially if you get backed against a wall by enemies. You want to be able to slide along the wall,
yeah,
to avoid attacks and stuff. Otherwise,
exactly.
You'll feel like you got stuck, and yeah.
I'm gonna actually change it to 1.0 F on the raycast. Actually, I should do 0.5 because this will be way too early. Actually, that's not as too early as I thought it would be. Cool. So we've got basic character entrapment here. Using our system now. As I do want to make that so that it will be nicer in a bit. I'm going to save scene, save project. Let's create folder, script, create a folder, materials, just getting organized early here. Create folder prefabs. We'll just leave test in the root for right now. Save scene. Save project. Basic movement and shooting mock-up. Very, very, very incomplete. Commit. Gotta start somewhere though, right? And let's see what people have to say on the channel, because we don't have anyone watching the channel right now. All right. Did I make it in time for stream? Obligatory disclosure agreement. I like that. Whoa, didn't know about Align with View. Align with View is awesome. Yeah, definitely keep in mind that there's Align with View, and there's also Align View to Selected, which could be useful. So if we're like, what is this camera looking at? You can click on the camera and be like, Align View to Selected, and it's like, oh, that's what that camera's looking at. So. Twin stick red ball generator. Sounds like most twin stick shooters. Yep. Good night, morning, afternoon. Shoot the bullet. All right, cowboy. Sweet. So, we're no one's complaining too much. So that's good. It's only been 13 minutes. That has to be a lie, right? Time. That's really hard. Delta time, man. Their time.delta time is broken on YouTube. Something. The timer, man. The fact that it was like, oh yeah, it's like 17 minutes, and it's been 26, so that's great.
They should be using
time since
real time since startup,
yeah,
and then subtracting it every frame.
Yeah, exactly. There you go. That way you will never be wrong.
That way they'll only be off by a frame.
Exactly. And no one cares about being off by a frame unless you're playing Unreal Tournament and someone's really picky. Did you ever see that big debacle about that there's one frame of like smoothing, like the input was handled ahead after the rendering or something, and as opposed to before, and there was actually people complaining. I don't know why they were complaining, but they were. So things we could do. We could make this a smoother interaction. We could test some enemy collision stuff. Kind of want to make that smooth.
So doesn't Unity have a way, I can't remember what it's called exactly, but of baking in movable area based on the angle of the geometry? Is that a pro only feature, or
you mean like the movement stuff, like the
what's in navigation?
Like the nav mesh stuff, yeah, that's Unity Pro, unfortunately. Okay. We might look into it. I'm not against using Unity Pro on a project at some point, but I generally try to keep it free as much as possible. We haven't done it before, although if we are planning on releasing this thing, I'd probably, at the very least, I'd want to throw some post-process effects on things just to make things glowier and nicer. So we'll see what we end up doing regarding that.
So the raycast allowing you to slide, are the rooms going to be basically geometric, or?
I was thinking pretty square at first, at least for the initial design. What were you thinking? Like more of a mesh type thing, or like?
Well, I was just thinking of how we would make it so you could slide along the wall.
Yeah.
And one way to do that is to rotate by 90 degrees. Rotate the ray that the first raycast was done by 90 degrees in the general direction of the movement input. So since you're holding up, it would rotate toward up, but 90 degrees, so that it would be pointing toward the wall to the right.
Oh, I see. So you hit the wall.
Or do you already have a?
That's not how I was going to handle it, but I want to think about this one first because it actually sounds kind of promising. So if you move it up, the rotate would be. So how do we determine the angle of rotation? Like which direction to rotate it?
Well, if it would rotate toward the direction that your movement input. You have a movement vector.
So right now the movement vector, if I press straight up here, it should be exactly straight up, right?
Yeah, and relative to what you're hitting, straight up is an angle off to the right of... Oh, wait. Yeah, we don't know the geometry of the actual object, so we don't know.
Yeah. Yeah, I'm going to... Let's see. So if we raycast... Hold on. I'm going to see what we get out of a raycast hit real quick. Raycast hit, and then we'll throw a hit in here somewhere. Hit, out, hit. Is that a position for it? Is that a real thing? Come on.
I think it's before distance.
Oh, it's because of this. Yep, you're right. It's before distance. Alright, so hits dot. We got distance, collider, normal, point. Yeah, normal's useful.
So normal is how we could find the direction that we want to rotate.
Normal would be pointing out.
So the negative normal would be pointing in the direction that we hit, and then the up would be.
So the normal is going to be pointing this. If we hit this wall, it's always going to be pointing this way. That's the direction the normal will always be facing.
Yeah, and the negative normal is pointing into the wall.
Negative normal is pointing into the wall, that's correct.
And then, how is it you find out the direction that that one vector is from another, the cross product?
Yeah, if we do a cross product, we'll get a vector pointing up or down directly. That doesn't help us too much.
But but you know, based on whether it's up or down, whether the first and second angle, what direction they are relative to the other. That's how you find out because Unity's vector 3 angle gives you a positive angle.
Yeah, no matter what.
So sometimes you need a negative angle, and you do the cross product to find out the direction of the. So if we had up, and we were figuring out the direction from the negative normal to up. And I'm assuming positive would be to the right, then we would rotate 90 degrees to the right and raycast.
I really think we're going about this a harder way than we need to be.
Maybe.
We just want the... Going forward.
Well, don't we have to do a second raycast anyway? Because if you slide, we still have to find out if you're going to hit the other wall.
Yeah. All right. Let's start typing our way into trouble. All right, so we want. What we want is the tangent is what we want. And the tangent is the normal crossed with up.
And we want that going in the direction of the direction that we were going, though.
Yeah.
Which is why I brought up the cross product.
Yeah, that is why you brought up the cross product. So if we do two cross... Yeah, let's try that. All right. So I'm just going to use some white space here real quick to plan this out. So... we take the vector 3.
We do it inside because we have our hit.
I know. We're gonna move. Oh, all right. I'll do it inside. Vector vector 3 cross, move direction and hit dot normal, and then we cross that with so this gives us either up or down, and then if we do a cross product with the normal again, it'll give us a tangent, hopefully facing the right direction because of the initial cross product. Let's see how this works. So vector 3 cross, move direction, hit normal, vector 3 dot cross. We recross this with the hit dot normal. And all we're going to do is debug.draw array. So just a draw array. Start and direction. So this is the direction start we transformed up position. Oh, if not physics.raycast. Well, if we hit it, well, then we need to do stuff.
So put that in else.
Yeah, for right now. Save, play. What else can we put in here? Debug.draw array, start direction, color duration. So let's do color dot red, and duration is 1.0f.
Is the ray the actual distance in that direction, or does it?
Yeah, it does it based on the distance. It shouldn't. It should draw forever because it's supposed to be a ray, but that's not what it does. So.
Is that automatically... Wait, is that all... No, because, well... Oh, cross probably returns a normalized vector, doesn't it?
It
So
doesn't have
probably...
to return a normalized vector, I don't think. But,
okay. So our move direction probably makes it a pretty small ray then?
Yeah, let's try it. Normalized. Let's see if that works. There we go. Alright, so it's drawing, it looks like it's drawing the, so if I press up and it goes against it, it goes, so I've got exactly the opposite of what we want. So what we want to do is we want to just reverse the terms of either of these and it should fix it. Save, play. So now it's facing up there, and if we press left, it's facing left. Good. This is the directions we want. Pressing up here, it goes there, and facing right, it goes there. Sweet. Sweet. Okay, this will work. So...
I didn't doubt it for a minute.
You didn't. You did not. You were stoic, and you stared at me until I accepted your solution, and it totally worked. So,
reject your hypothesis and substitute my own.
So we're gonna do another raycast, physics.raycast, and we're gonna raycast along this direction. Transform position and that thingy. I'm going to call this vector 3 tangent equals that. So now we can do tangent and tangent. So tangent 1.0f. We'll just use that again, just hard code it for right now. So if and then else. Let's just do this for right now and see what happens. Save. Oh, not move direction. Sorry, we want to do this in plus equals tangent times. Tangent is normalized, right? Yeah. Times speed times time dot delta time. Save. So press up. There we go. Press right. There we go. Yeah. Yeah, that's pretty slick.
Go into the corner.
All right, going into the corner. Holding it up into the corner.
Now hold left.
Holding left.
Okay, cool.
Maybe I can jam myself in there. No. Even if I... So I can kind of wiggle myself in, but we still get out real nicely. So that's awesome. That worked. That worked out real nice. Double cross product for the win. So, I'm going to describe the cross product thing real quick. I'm actually going to do this again because we're not doing anything else in this case yet anyway. So what we're doing here is gotta get the camera up if I can. Camera. So cross product, what it does. We've described this on the show a couple times, but since this is a new thing, I like to go over this stuff as we do it. So a cross product takes two vectors that can be pointing in any directions. If they're parallel, I think it has some sort of exception or something that it doesn't like. I don't know exactly what it returns when they're parallel. But if they're anything but parallel, what the cross product does is it returns a vector that is perpendicular to both vectors. And so what that means is if you have two vectors that are like pointed kind of like this V thing, you would get one that points out or down, depending on which direction you go. If you cross one with the other, you get the vector pointing up. And if you cross them the other way, you get the vector pointing down. And that's... So what we did is we did this, what I'm going to call a crosswalk. So we did two crosses. The first one is the hit normal in the move direction, which that will give us either... And actually, let's go ahead and show those real quick. So the first cross product... normalized.
I think you should comment out our second move just so we're not creating a bunch of lines right next to each other along the wall.
Our second move? Where?
So that we sit in place when you go against the wall, just for the demonstration.
Oh.
Because you want to show the ray, but otherwise
yeah,
you're going to
good
have
point.
a bunch
Good
of
point.
rays
Gotcha.
on top of each other.
So we're going to make this one green, though. And we're going to... I see what you're saying.
Did you switch it back to the screen? Or is it on the face?
It is... Oh, it's still on the face. People watching me pick my nose. Main screen. Thank you. So I'm just creating two debug draw arrays here to show each step. So hit dot normal. Wait, no. I want this whole thing. Okay. And this one we will do color red. So maybe I should actually do 4 colors so we can show everything. So yeah, let's show the other two things too. So
is there like a dark green or something?
It probably is. Let's see. Dot. No, there's not. There's just green. But I'm sure that we could put in an actual color thing if we need fancier colors. I'm just going to do dot yellow, and magenta. So the first one is going to be move direction. This one's going to be hit dot normal.
I'm glad they have a normal for the hit.
Yeah. Oh, it's so nice.
Otherwise, we'd have to figure it out
All right.
from the geometry of the shape we're hitting.
I'm going to do that, and we're going to pause it. So where is the yellow? So the yellow is our move direction, and our move direction is actually not normalized, so it's very, very small. Let me actually change that so it's normalized. Dot normalized. Save. So I just wanted to show the whole thing that we're doing. So, pause. Whoops. Pause. All right. So, yellow is our move direction. So we're moving that way. Purple is the normal of the wall. So this will be pointing away from the wall no matter which wall we touch. So if we touch the other wall, say going this way, we've got it going that way. So I'm going to pause it here, and you can see that what happened was we crossed, and I may get actually let's get the order of operations correct. So we crossed the
hit normal with the move direction.
The move direction. So we cross the hit normal with the move direction, and that gives us our green one, which points directly up in this case. And so we have this one pointing up here, and then we recross that with the hit normal again, and that gives us this final red vector, which is in the direction that we can go. Now, if we press right over here as opposed to pressing forward, you'll see that the whole thing is kind of flipped upside down. And this is the reason that this worked for us, is because when we get the cross product, we get a downwards cross product here. And then when we do the cross product again, we get the direction that we wanted. That's the reason that we had to flip these two terms. We could have either flipped these two terms or flipped the internal terms, which is what we did, or we could have flipped the external terms, and it would have worked exactly the same way. But yeah, so that's how we walked a cross product into a tangent vector that we can then follow along to check to see if we can move or not. So yay. I guess I'll leave this stuff in case people want to see it. Save project.
We can move again.
Oh yeah. Now we'll actually slide against things when we do it. Yay! Yay! Woo!
We should add something that puts debug
Let's work
log
on the
for
other
what
side.
buttons you're hitting in the corner or something, so that they can see what you're pressing.
You know, that's actually a really good idea. Yeah. Let's. At the very least, we could put the axis info. Yeah, we should definitely have some sort of button thing. I don't feel like setting up something like that tonight, but yeah, that's a good idea for shows in general, honestly. Alright, right now, if I shoot in a direction and try to move in that direction, it makes me very unhappy. Let's fix that real quick. So, right now, move on to axis input. We're going to add a public layer mask equals -1. Save. We're going to place this layer mask into both our array casts, so I think it goes before the distance, right?
I don't think so.
Okay. Where do you think it goes?
At the end.
All right. You were right.
I think it actually was showing it to you when you started entering it in, because there's not really anything longer than
Crazy.
Position, direction, out hit, and distance, and layer mask.
So is this right for the shorter one? Origin, direction, distance, layer mask. Yep, that works for that one too. So, cool. So, so now we have a layer mask component, and I'm going to put these on a layer. We're going to call it player. Actually, let's call it level collision. We're going to put these guys onto the level collision layer, and we're going to go into our player and change it so that it cares about the level collision layer. Play. Yay, we can slide around. Yay, I'm going to turn off the gizmos so that we don't have that stuff on there.
Now shoot bullets and see if it.
And now if I shoot bullets,
you down or anything.
Bullets shouldn't bother me anymore, and they don't. Yay. Bullets definitely are going through walls right now.
Oh, the bullets use move forward, right?
Yep. So we're 10 minutes early. We got actually more done than I thought we were going to get done today. We even got something fancy done. I like it when we get things that are fancy done. Not that this is terribly fancy, but I mean it's fancier than what I was planning on doing for the end of the show. So
what was that?
Switching over to something else. We would have come back to it. We've gotten something, but because I wouldn't have liked the game if we had that stringent rules about gliding against things. Yeah, I like that. Let's make a training dummy. We already got the ability to shoot, might as well make it so we can shoot something. So, what are we going to do? We're going to create Capsule Collider. We're going to set the thing as a trigger. And so we can set these as triggers as well, can't we?
Yeah, because we're raycasting.
Yeah.
So.
Actually, I think I'm just going to make the thingy have the trigger. That way it doesn't feel as weird. So we're going to use this. We're going to have it as is trigger. We're going to have a move forward script, and let's create a script called C# script. Damage. Damage on trigger enter. So all we're going to do is public float damage amount equals 1. Should be a float. Yeah, we should make it a float because we can cast it later. Let's just do 1.0f to default. And what this will do is on trigger enter, we will do on trigger enter, just do a send message. We'll do collider col dot send message. Actually, let's do upwards to be safer, and the message will be damage, and the amount will be object value, so we can just send damage amount. Save, and then we're going to create let's see, Destroy on trigger, enter. I don't know why I copied the description. That's actually totally wrong.
No, it's completely correct.
Yeah, well, it is true. Updating is only called once per frame, but it's kind of in a weird spot to be describing it. And so
Just
on this
copy
one,
and
we're
paste
just going
that
to do...
everywhere throughout the script.
This one we don't even need to know what we're colliding with, so we're just going to do on trigger enter, destroy game object, and then finally, so let's put these on the sphere, and save scene, save project, apply this, delete, play. So if we, so right now it's hitting our cube. So let's fix that real quick. So we need the sphere. We're going to do layer, add layer, player, bullets. Sphere is going to be on the player bullets layer. We're going to also create a layer called player. Player is going to be on the player layer. And then we're going to go into project settings, collision. Physics, thank you. And we want player bullets to collide only with level collision. Well, actually...
And default. Is the cylinder on default?
Player definitely shouldn't collide too. So the cylinder is on default right now, so I guess, yeah, we should probably have default in there as well. Actually, these things should probably collide with a lot of things, just not collide with the player. Let's just leave it all there, except for the player collision right now. Save all, save project, play. So now when we shoot, they go away when, well, they don't.
Is there a rigid body on them?
Thank you. Thank you. These need to have a rigid body on them for this to work. At least one of the two components in a collision have to have a rigid body.
Sometimes... Doesn't it work better if it's on the thing that's moving too?
Yes. You don't want to move anything if it doesn't have a rigid body, basically, if you're planning on doing that. So there we go. We've got it. It's hitting things. They're destroying. We're not actually catching the send message. We're getting this message. It has no receiver. We could make it so that this is neglected for right now, but I'm just going to leave it there, and we're going to continue work on this next time. So...
Next time, all we have to do is run the game to see where we left off.
Exactly, and we'll see those errors, and we'll be like, "Oh, here's what to do next." That's what I figured. That's probably a good choice. So let's just put the rest of the stuff in. We're going to call this basic bullet stuff in progress. Commit. All right. So, thank you very much for watching. Hopefully you enjoyed the show. If you have any questions, please email me, pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Please support us on Patreon, patreon.com/cookingwithunity. We really appreciate your support. Please donate if you can. And, thanks for watching, and I'll catch you tomorrow morning with another Breakfast with Unity, and we'll see how this project unfolds in the next few weeks. You guys have a good one.
Good night, everyone.
Bye-bye. I'll wait for Phil and